In this video, we'll try to see the relationship between existential and universal quantifiers. Before that, let's see what I mean by universal quantifier. Once again, universal quantifier for all x, p of x, mean for all x, p of x holds. And this also means, this is existential quantifier as you know, p of x, there is an x, or for some x, p of x holds. So let's see how this can be related when we apply negation over each of these quantifiers. To do this, consider the following example. Let the universal set be, this is the universal set, the set of all integers, and let p of x be this set, x squared greater than 0, and q of x be x squared less than 0. Now for the first one, for all x, p of x is, this is false. Do you know why? Now, if you pick any element randomly from this set of all integers, as far as that number is non-zero, x squared is obviously greater than 0. But the only number where x squared greater than 0 is false is the number 0. Because of that single number, this universal quantifier is false. So this indicates because this universal quantifier is false, its negation is true. So the negation of for all x, p of x is true. The negation is true. Well, when we say this, for all x, p of x fails to be true because there is a single element where p of x is false, So the negation of all x, p of x, can be directly related to the following. This is equivalent to, there is an x says that the statement p of x is false, which means there is a single element, this time 0 squared is not greater than 0. Similarly, if I take for some x, q of x, this statement again is false because you can't find a single element from this set says that x squared is less than 0. Even for 0 is not less than 0. For other numbers, it's obvious. Therefore, there is an x, q of x is false. This is false because we fail to get a single element where q of x is true. This also indicates the following rule. Because this one is false, its negation is true. Hence the negation of there is some x or a single x says that q of x is equivalent to saying for all x, we know that statement, this statement for all x is false, which means its negation is true. Hence the negation of q of x. Therefore, these two statements can be used as rules to establish the relationship between existential and universal quantifiers. So this is how we relate existential and universal quantifiers when we apply negation over each of them.